Okay, good evening. Welcome to
MinuteMath96.
MinuteMath96. Is that a black marker you got?
Yeah.
Okay, probably made a different color, but that's okay for now. This is a geometry problem that is from one of the old AMC8 tests. And we haven't talked about this at all. So I thought we'd just do this for fun because this is hard to do problems when you don't really know anything about how to do them. You know what I mean? Okay. Two 4x4 squares intersect at right angles, bisecting their intersecting sides as shown. Okay, so here's the picture. So you have some squares that are on top of each other. The circle's diameter is the segment between the 2 points of intersection. What is the area of the shaded region created by removing the circle from the squares? So we have two intersecting squares that bisect, their sides bisect each other. And we take the circle out of it, and we're trying to find this area. Well, that's a tricky problem, right?
Yeah.
What would be an easier problem, first off?
Find out the area of the circle.
Finding out the area of the circle would be an easier problem, that's true. What else would be an easier problem?
Finding out the area of the... well, probably not finding out the area of the shaded region right now.
Right. Not the area of the shaded region, because that's the problem we're trying to find. There's one other thing that would make this problem a lot easier. If one of the shapes wasn't part of this problem.
Well, we want to remove the circle.
We want to remove the circle, but let's solve the problem first, pretending that the circle's not there. Okay? So I have a square, a 4x4 square, and a 4x4 square over here. Okay? First of all, what's the area of a 4x4 square?
It's 16.
16. What's the area of this 4x4
16
square?
as well.
16. So do you get an area of 32 when they're laying on top of each other?
Yeah. No, wait. No. Yeah, you do.
Sure.
Well, no, because of this area.
Okay, what do you have to do with this area?
You have to subtract... you counted this area twice.
Right, you counted this area twice. So now, yeah, okay, give me that. Okay, so it does say they bisected the sides, right?
Yeah.
Okay, so what does bisect mean?
It means they cut the sides in half.
Okay, so what's the side length of this square here? 2. So what's its area?
4.
4. So the area in here is 16 plus 16 minus 4, which is what?
It's 32 minus 4, which is 28.
28, okay. Okay, so we got the area. Now we have this pesky circle here that we have to figure out. Okay, so we have this region that has an area of 28, but then we draw this big circle around it. And the only thing we know is that there's this 2x2 square inside this circle. You know, here's the thing you don't know, because we haven't ever talked about it. There's something called the Pythagorean Theorem, and I've got a right triangle here. This is 2, this is 2, that means this is 2 times the square root of 2. Okay? You never knew that, so don't worry if that doesn't make any sense. If the diameter of the circle is 2 times the square root of 2, what's the radius?
It's 2 times the square root of 2 over 2.
Okay? 2 times the square root of 2 over 2, which is what?
So just 1 times the... it's not 1 times the square root of 1.
It's definitely not 1 times the square root of 1.
It's 1 times the square root of 2.
It's 1 times the square root of 2,
Square root
which
of
we just write as the square root of 2. Okay, what is the formula for the area of a circle?
It's pi times the radius squared.
Pi times the radius squared. So if the radius is the square root of 2, what is the radius squared?
It's pi times 2.
Pi times 2.
Or 2 pi.
2 pi. Okay, so the area of this circle that we took away is 2 pi. So the area of the shaded region is 28 minus the circle, which is 28 minus 2 pi.
And we can't get any simpler.
No, that's as simple as you get. Now, but there's the reason I did this problem, because even though you didn't really know how to do this, because you didn't know about how to find the area of the circle. This is a great example because you break the problem down into an easier problem. The circle makes everything complicated, so the first thing we did is we solved the problem without the circle. Okay, just 2 overlapping squares. They overlap. We said, hey, one square is 16, the other square is 16. When we add them together, we get 32. Oops, except we have this overlapping bit that we actually counted twice, so we have to subtract it away. That overlapping bit had an area of 4, so we knew we had a 28. Okay, aha, so now we got a 28. Now we got to find the area of the circle. Well, it turns out that you can find, by a little geometry, what the diameter is 2 times the square root of 2. That means the radius is 2 times the square root of 2 over 2, like you said. Square root of 2. Area formula is pi r squared, which is 2 pi. So 28 minus 2 pi, and we're done. I forgot to look at how many people got this right, but this is a tricky geometry problem. It's definitely tricky. You got to break it down into pieces, but it's important to learn how to break things down into pieces.
Okay, good job.